Good afternoon, everyone. I think it's good afternoon for most of the people in US. Um, Welcome to the monthly webinar by the ESIP Semantic Tech Committee. And today we have the pleasure to have Sky Bristol from USGS to give us a talk on the Geoscience Knowledgebase. Short name is the GeoKB. He recently has been working on this topic, and also I know he is deploying this to some other applications in the USGS scientific activities, including those on critical minerals, and also a number of collaborations with other institutions with similar efforts on linked open data and also applications in earth and environmental science, especially mineral exploration. So next, I will just give the floor to, I believe most of you already know Sky, so I will just give the floor to Sky for his talk.
Great. Thank you very much, Marshall. I appreciate the opportunity to share a little bit about where we are. We're kind of at I think, an interesting tipping point with this whole effort. And so it'd be great to share a bit of that, some of the interesting things that we're working on, and see what kind of feedback and input we might get from our community here. So I've titled this a pragmatic approach to building a linked open database of our entire USGS scientific portfolio. And I'm going to start with a little bit of motivation and history for this, going back in time just a bit to how we got to this point and a number of steps along the way to that. I'll pose a little bit of a challenge, both for ourselves in USGS and maybe for others in the community, about living up to our ideals of openness and transparency, and how we're going about trying to force that. I'll share a couple of specific aspects of the Geoscience Knowledgebase development that we've codenamed ISED and IRED, kind of two different use cases that we're pursuing through that, to give you some examples of where this is heading and kind of lay that story out, and kind of finish with some questions on how do we really move this to our next step and achieve activation energy to really make this a going concern. So a little bit of prehistory and what motivated this whole pursuit, sort of what I and a number of others have been doing here over the last 20-something years toward USGS becoming an integrated science agency. That's something that we've called ourselves for a long time, and I'll kind of weave in, how this whole effort around the knowledge base is really associated with that. So way back in the late 1980s, early 1990s, I started my work in government. I actually started as a high school volunteer, so very young, getting out doing some interesting field work. And one of the projects that I worked on for a number of years was in the southwestern U.S., kind of the northwest part of New Mexico and that area, where we were examining a project that the Department of Interior had helped to fund, the Navajo Indian Irrigation Project, to develop farmland out in the desert through irrigation works and whatnot there. But we were having trouble in a number of areas. It was being discovered in the 80s and into the 90s with selenium in particular, and teratogenic effects on birds and other species from that. And it ended up being a really big, interesting, integrated science problem. We just didn't know it at the time as we were heading into this. We were a bunch of biologists trying to figure out biology things. We didn't really understand the full picture of what was going on hydrologically and geologically in the area, in terms of the Mako Shale Formation and black shales in general. The contribution of selenium, from those, and all of the different actions that lead to that, from irrigation and agriculture to recreation and other challenges that come up over time. And so it was a really poignant example of why, in pursuit of any problem in Earth system science, we need to bring multiple disciplines together and multiple people together, and a broad understanding of what's going on in order to really solve a problem and help to address it in some way. And a lot of that really led me to be really attracted to things that were going on in the USGS at that time. In the early 2000s, 2004, I moved over to USGS to take on a job trying to pursue the data aspects of integrated science. How are we going to do integrated science? What are we going to need to do with our data in order to enable integrated science to happen in some way? And so I got involved in a number of things there. We put out this talk at a GSA conference back in 2007, laying out a blueprint for how we were going to go about this. Linda Gunderson, Kevin Gallagher, and myself, and a few other folks really worked to kind of design some of that. In 2007, we released a science strategy, or shortly after 2007, that really kicked off a full-scale reorganization of the USGS away from academic disciplines toward these organizational units that were really designed to address cross-cutting issues with transdisciplinary science in some way. And so we started pursuing those things in a variety of ways, and we did a lot of experimentation with how we're going to go about trying to integrate across the board. And we learned a few things along the way in that, and I kind of called these maybe transdisciplinary science ingredients. Kind of some of the lessons learned. We learned that management-imposed integration, generally backfires. We tried setting up integrated science centers and really forcing people to work on projects together that management thought were good, important things to do. But they kind of failed after a while because it was not really an organic development toward this. We learned that there's a lot of really interesting serendipitous integration that happens when personally invested individuals get together and figure out how to solve a problem. Those really have the highest yield a lot of times in terms of products and really new thinking at the disciplinary boundaries. We've learned that a tangible impact on scientifically informed decision making is a really powerful motivator. I mean, when there's a management problem, something that society is trying to solve, or a particular resource management organization is trying to solve, when we can put our heads together and figure out a way to inform that with an understanding of what's going on across all of the different realms of Earth system science that may impact that, that's really a powerful motivator to move things forward and get things done. So that stakeholder engagement is pretty key. We have learned that really good sustained institutional investment is a foundation for this. And we've done some good things in terms of developing our community for data integration, closely aligned with ESIP, our John Wesley Powell Center for Analysis and Synthesis, and our USGS Innovation Center. Those are three major efforts that, while sort of management directed, were very much grassroots led efforts to say, how do we get together and learn how to practice and do things better around the edges of our understanding in these areas. We've also learned through time that technology can help, just not the kind of flash in the pan types of things that sound really cool today, but may really not go anywhere in the future and can't be sustained in some way. And I'll talk a little bit about that as we work through this. We've also learned very powerfully that there's no data integration without knowledge organization. We can't just munge a bunch of things together. Syntactically, we might be able to do that. And the syntax of data has become very easy. It's very easy to ship data around into myriad different formats as needed very quickly. The computational costs have come way down, but it's still the semantics that are the issue. It's what's underlying that. Can you really put these things together? Do you need to run them through a transformation of some kind? Do you have dissonance in what certain things mean that have to be resolved in order to put data together even within a given discipline over time, let alone across disciplines, and turn that into something that can be used. So this effort has been going on for a long time. We had things that were happening in USGS when I came into the organization in 2004. This idea of an integrated information environment had been out there. There was a whole other big thrust to try to create some sort of a data integration platform or something like that. Lots of visioneering about it and prototyping. And some good things came out of that. A few good lasting things came out of that, but there were a lot of struggles along the way. In 2006 or so, we had a thing called the Geospatial Information Office. That's what I came into. We started envisioning what would become ScienceBase, which still exists today. The linked data aspects of that were kind of interesting. They were really inspired by an early conversation that I had with the Freebase guys, I think in 2008 or 2009. I tried to dig around, find some notes on that. I couldn't come up with those, but I got pretty inspired by what Freebase was doing and thought, geez, we need to have that for our platform. And of course, Freebase kind of worked its way into the Google Knowledge Graph as Google took it over and then kind of spun off. Some of it still shows up in Wikidata and whatnot. But over time, ScienceBase kind of evolved more as an institutional repository for data objects, and it's done a great job of that as we've implemented data release policies and whatnot. There are thousands of data sets online now that weren't before, but it really had to abandon most of its linking and integrating ambitions in order to focus on those particular efforts. We did have a few other things along the way. We did this thing called the Geospatial Management Information System at one time that led off into something called Who Does What Where. We had this brief flirtation with a Schlumberger group to try to use something that they had to bring a linked data type of system together. We weren't calling it a knowledge graph at that time, but a lot of it was that sort of idea. And then in 2018, 2019, a number of folks were involved in something called EarthMap. It was a administrative initiative. I got involved in that at the time, and it kind of gave us a space to experiment with a new approach, something we codenamed ISED at the time. It was kind of a tongue-in-cheek name, but a new way of thinking about this, new kinds of ways of applying really knowledge graph capabilities to the picture to bring these things together. And so from that point forward, we've now absorbed that idea and some of those technologies into something called the Geoscience Knowledgebase. This is being built out of a particular mission area, but it's focused on use cases there, but it really touches on the entire USGS portfolio from a meta standpoint, at least in terms of our people and products and many of the subject matters and whatnot that we're trying to deal with. So we're trying to build it to really scale into all of those other areas that we need to touch on. We've been experimenting with how we use that data to assess our capacity in USGS to pursue strategic objectives. We've developed this collaboration with Wikimedia Deutschland, Wikimedia Germany on using Wikibase and some connections to Wikidata. And I'll talk a little bit about that. And there are comparable efforts going on in USGS in hydrology with GeoConnects and the Internet of Water. Dave Blodgett's very involved in the Intelligent National Map that Dalia Varanka and others have kicked off, and some nice connections there to the Proto-OKN effort through NSF. So we're hoping that a lot of this will converge, and we'll be developing toward an overall capacity in some way that moves us forward. So I want to make a little bit of a case for really why we're doing this in the way that we're doing it, and why we are using a platform other than something that USGS owns in the Wikibase cloud environment. And that really comes down to trying to live up to our reputation. USGS has a long and I think a well-earned reputation of being very open in our science and our data and the information we put out. In fact, that's probably bit us a number of times. I mean, we have global competitors who have taken our geoscientific data that we've put out freely and used it to gain advantage competitively in certain areas, such as mineral development. And we can argue if that's a good or a bad thing, but we've put a lot out. But being somebody in the organization, I can say that we still have a little bit of an ivory tower problem sometimes, where we expect people to come to us and get our information. We expend a tremendous amount of energy trying to build good websites and good web apps and all of that so that people can explore and work with our stuff, as opposed to pushing our information out and projecting it out into the world where other people are going to get at it on the platforms and the tools that they use regularly and can maybe integrate more readily into their environment. And so I think we need to be looking toward that more and more and figuring out how government does its thing, and yes, does need to provide an authoritative master source for the information that we have. But at the same time, we need to participate in the developing global knowledge commons directly and actively in terms of how our information integrates there. And I'll talk a bit about how we're trying to do that here. So, I mean, Wikidata is a very interesting thing. I just posted a couple of examples here that that struck me as I was looking back through Wikidata a number of years ago and trying to think about, okay, well, how would we use this? How would we participate in this? What is the footprint or the developing footprint of things that we care about in USGS in that space? I ended up getting into some of my first online arguments with other people doing things in Wikidata, like a guy that went through and wrote a bot to use traditional male and female first names to assign gender values to scientists. He was doing some interesting work related to gender bias and whatnot in science, which is great. But he introduced a whole bunch of claims into the system that really aren't backed by anything more than just somebody's name, and that's kind of not a great thing to do. So there's lots of crazy messiness that goes on in this melting pot where people are trying to make sense of the world across cultures and domains and disciplines and languages, which is really cool. But it also creates a lot of semantic collisions and messiness that we have to be aware of in some way. So in looking at the USGS footprint out there, even today, there are 9,299 connections, essentially linkages in some way through some predicates to the USGS specifically as an institution. We're an employer, a publisher, an owner, affiliate, author, creator. There's quite a bit of confusion in that and dissonance in terms of what those links are that have kind of developed organically over time. But it's still a sizable piece. And, a lot of what we're trying to do in the geoscience knowledge base work is inform that by producing our own take in this same technology base in a way that other people can work with. And we're doing that using another project of Wikimedia Germany called wikibase.cloud. They've kind of firmed up the basic technology stack of Wikibase and all of its pieces and figured out how to run a bunch of Wikibases in the cloud. I got involved in their early invitation beta and started spinning up the GeoKB at that time, and we're still number 4 in the list in terms of the numbers of items as we're continuing to push things out to get into that world. And the whole idea of this, to a great extent, in Wikibase.cloud is to let individual domains build and develop knowledge and organize their knowledge within their space in a little bit more controlled way than what you see going on Wikidata, where it's kind of a free-for-all. The system has gotten to be so big and so unwieldy in some ways now that it's getting to be very challenging to try to do anything at scale across that. So part of the idea of Wikibase.cloud is to say, can we have individual domains do something that's adjacent to that, developing connections into Wikidata, but still be managed and controlled within their own overall domains. So I think that's a really interesting experiment, and it's been a real pleasure working with the Wikimedia Germany folks and other people involved in that overall community as we're starting to figure it out. So a little bit of a dive into sort of what we're doing and how we're going about it. So going back to this ISET idea, this was really a focus on our people, what they know and what they produce toward use cases around assessing our institutional capacity to do new things, to pursue new scientific objectives as we develop strategically where we're trying to go. We need to have some place that we can go and say, who have we got? What are they doing? What do they know? What are our gaps? And how do we go about filling those in some way? And so if we look at kind of a normal scientist digital footprint, we have aspects of that are open and proprietary both. They're open things like we have our own professional profile pages for people. We have ORCID records for just about everybody over the last number of years who's at least publishing and contributing in some way. Those have, open information that's available, some of it that we contribute, some of it that others do. We have Wikidata, we have OpenAlex that grew out of the Microsoft Academic Graph. There are a few other things out there that have some aspect of that. And then there's proprietary stuff. There's Google Scholar, there's ResearchGate, academia.edu, these other environments that also do really cool things, but we can't really use that data openly. We can be aware of them, but they kind of serve a different purpose, and have their own take on things. The information that's out there kind of breaks down into a couple of categories. We have, the information as data that's really organized and structured in a way that we can read with machines or AI can work with. And then there's also information that's only for human consumption. And I have this in here because I'm kind of using this work to help point out some areas in USGS that we need to improve a fair bit. In our profile pages, which have some of the unique information associated with people that you can't get anywhere else. They also highlight people who are not necessarily publishing scientists, so they help us to fill in some of those gaps where those systems that are really geared toward publishing scientists are doing maybe a better job. But we're doing a pretty terrible job in terms of managing that. It's not available for machines to read. It has to be scraped from web pages, and we kind of do crazy stuff like, disappear people after a while, and you just have to guess that they left, or we, flag them as a former employee, but delete all the rest of their information so that, we don't have that kind of permanent record. So we need some improvement in some of those areas. We're representing these in the Wikibase structure that we're using as the Geoscience knowledge base right now. People are entities, so they're the subject of different claims, statements associated with them, such as knows about statements. Knows about statements can come from places like OpenAlex, like our profile pages. There's a little bit of direct linkage that goes on. There's a little bit of AI assisted linkage that goes on as we process through trying to link people up to topics and concepts and things that are in the system as a whole. And we also correct for, as we're bringing people into this database environment, we're correcting for some of those issues of not having data in structured formats by storing it within the wiki pages themselves that are associated with those items. And that can be read by software tools, can pull that in. It's just JSON, mostly JSON link data, mostly conforming to the schema.org standards. So we transform information from these messy sources like scraping web pages, turn it into appropriately formatted schema.org so that it's available there. In the future, we hope that that schema.org will be served directly from the pages themselves, and we can just pick it up using, Gleaner and all the different kinds of tools that have been developed over time to do that sort of work. Unfortunately, we have to do a lot of heavy lifting right now to try to get there. So we're using that as our kind of common linkinator as we work through publications and data sets and people and organizations and all of these entities is a properly formatted schema.org document that's kind of our ideal standard for what we want those things to look like. And then we turn that into the set of claims and references and qualifiers and whatnot that are in the Wikibase structure itself. So in terms of the kind of ISED parts of this, we've got, thousands of humans. Most of those, are USGS people, but we have a lot of other humans as well, or co-authors, and we do a fair bit of co-author analysis in capacity assessment to really understand who we're partnering with and where we need to strengthen those partnerships to make up for things that we need. We have links to organizations, including our USGS organizational units and the mix of government and academic and others that are out there, leveraging the Research Organization Registry and OpenAlex and a number of other sources to fill in the blanks and bring a lot of those together. We have many thousands of our published products, including our journal articles and our USGS publications, data releases, scientific models, many of our web articles. We also scrape and use those to help represent essentially projects or in-progress science, things that are going on. And we've linked those all together to over 4,000 concepts that are really part of the ontology that makes up that underlying system. And so that really brings us to that piece of things. So for capacity assessment use cases like climate change science, Olivia Pierman has led a paper on that, and we'll be putting that out fairly soon on that particular use case. We're getting ready to work on a drought science use case this next year, this year that we're starting into right now, that will kind of really build on that process. So we start with building the idea of a line of inquiry around something like our pursuit of climate change science and what that looks like. And then that connects out into the graph, into all of these topics and concepts and whatnot that make that up. And then all of the people, organizations, products, projects, activities that are going on that are associated with those in some way. And Olivia has developed a companion application that goes along with what's in the knowledge base to provide people a curation environment to go in and look specifically at a topical area and provide input and corrections as to what's there that needs to get fed back into the knowledge base itself over time. So another major use case that we're working on right now is something we've kind of tongue-in-cheek called iRead. And this is really about transforming all of our products, including historically and currently things that we've built essentially for human consumption into AI-ready data. And this is where we get a bit more into the more geoscientific and mineral exploration use cases that Marshall was mentioning there earlier. So USGS is sitting on thousands upon thousands of documents and images and mystery data sets. Most of them are public and available. This little graphic was something I just threw together earlier that really just shows directly from the Geoscience knowledge base the distribution of the different kinds of publications and whatnot that we have in our system. And many of these are still valid, viable references and documented information that needs to be turned into analysis-ready data, particularly when it comes to things like our mineral resource assessments and energy resource assessments and other things that are based on science that has been done for many, many decades that really needs to be turned into something new. But that's a hard process to go through and do. So we're using the knowledge base, and particularly the development of our geoscientific features and ontologies within that, with a little bit of USGS flavoring as we need to kind of impose our own particular view of the world into that. To help to drive kind of an emerging set of AI capabilities that we're trying to get as much as possible from partnerships like with Shannon Peters and the Geo Deep Dive XDD folks. We've got a big project that's working through a whole AI tool set, including kind of graph RAG approaches, documents into graph fragments, back into graph methods to help us feed back into this whole process, all of which will drive, various kinds of data technologies that need to come out of that, improved geochemistry data sets, improved services from those for use in analytical work. But again, none of that happens until we have the stuff in the middle that helps us translate and understand how we need to connect one thing to another. So we're sort of at a point with all of this where I think we're at an operational tipping point, and we're really asking the question of what is it going to take now to get this system and this ecosystem of capabilities that we're putting together to the point where it enters into practical use for a lot of different things beyond just experimental use cases and whatnot that we're working it through. So I want to share a few characteristics of what we have, kind of a number of interesting problems that we're working on right now, maybe in a way to help spark some conversation here and some input to where we're trying to go with all of this. So one kind of cool thing about working with this technology in particular is that the Wikibase is also a wiki. So it has pages and lots of other functionality that are behind it, and those pages are structured and they can be read by machines and they can be read by people, and there's lots of information that we can put in there. So I showed some examples earlier of where we're shoving structured data in JSON. We've also done some things with YAML, experimented with that, and so that you can read that out and take that into very structured forms. But we're also documenting what we're doing along the way, and we're documenting the different dynamics directly in line with the structured data that's associated with those. And that stuff is available for search. It's available for people to work through and to build upon over time. And so the whole platform is really developing around that, and we're trying to use the documentation piece of that to help guide people toward the right protocols and the right methods to use in working through and contributing to this. The other cool thing about the Wikibase stuff, on the one hand, it's like ancient technology, right? It's PHP and these old tools in a lot of ways, and some of them are pretty probably need a little bit of love. But on the other hand, there's been a lot of stuff that's been developed around that. There's a pretty decent user interface so that people can come in and provide manual one-off contributions in different ways. There are scripting tools and things built in, such as quick statements and connections with OpenRefine, so that people can contribute larger chunks of data that they put together as tables or CSVs, other ways of organizing data in some way. There are some great APIs out there. I've got a package called WB Maker that I'm building a lot of our business rules into, but that's built on top of Les Mist's Wikibase Integrator tool, which is in pretty heavy use in developing bots for Wikidata and other Wikibases out there. So there's a kind of mature software ecosystem to work with. And there's also, one of the more important things is this kind of very robust revision history of every single thing that goes on. So whether it's a bot contributing or a person contributing, whether they're coming in through a form or quick statements or open refine or a script, that is all getting captured as individual revisions and is going into the history of everything that gets contributed to the system over time. So those are some really key features to have. And even though there might be some better technologies in some areas to do what we're trying to do, these features are pretty important and would be hard to replicate in some other areas. So another a big piece of what we're working toward is to establish as many same as relationships as we can with other ontologies, with other information systems, knowledge organization systems, whether they're formal ontologies or not. And this is a quick distribution of where we have same as relationships, at least the domains of those. We're still working through a number of sources that we need to digest a little bit more fully. Some of the earlier work in GeoSciML, the geoscience ontology work that we're bringing in. There's still ongoing work to really make sure that the USGS definitions associated with those concepts align with definitions that have come about through other parts of the community in some way before we firmly establish some of those relationships. And we have a lot of those relationships developing with Wikidata itself. Again, a big part of the point of working with this Wikibase.cloud environment is to say, here's what we know about some of the same things that have been posted into Wikidata. So we've got a lot of subclasses linked. We have a lot of instances linked. Many of our properties are really used in essentially the same way. And so we've established those relationships. I say kind of, sort of, because we're also still working through how do we provide the caveats when there's a little bit of divergence in terms of how we're actually treating this particular concept. But this is an important aspect to kind of getting the ball rolling and really making this work, because we need to bring people into this environment based on their own context, what they already know. And if they have ascribed to a particular set of concepts and how those are organized someplace else, we want those to be represented here very well. So, we're working quite a bit with especially many of our senior mineral assessment geologists to digest some of the classic references that they've used into this particular form for use. So there are a couple of design challenges and things that we're dealing with currently that I wanted to mention just to see if other folks are dealing with some of these same kinds of things. We needed to develop a backup solution for this entire thing that we're doing in wikibase.cloud, so that if we need to move technologies or change something, or we change policy and USGS decides it doesn't want to work with those guys, we have a backup plan and we can move all of that out to some other technology, maybe a different Wikibase instance, or something else entirely. So we keep a synchronized dump of everything in the base JSON format that it is. But that's also allowing us to work on a key addition to something that's not in Wikibase or Wikidata currently, and that's the ability to have query capabilities into who or what process or what bot introduced a claim at a particular time. We think that's going to be really key, because we'll need to selectively decide based on those circumstances what it is that we're going to trust from this environment. There are a bunch of problems right now in Wikidata with BlazeGraph. They're actually getting ready to split Wikidata and do some kind of background engineering to try to make some of that work better. But BlazeGraph itself is old and isn't really being maintained. We need something else for that. So we're experimenting with Clever, a group out of University of Freiburg. It's pretty fast, and they've done a really nice job of integrating Sparkle and full text search together. We think that's going to stand in here pretty well, and so we're just kind of waiting to see if that's going to get implemented within the Wikibase stack, or if that's something that we need to build out on our own in some way. And we're also dealing with this whole issue of shape expressions or shackle or some other method of defining our schemas, and then or property constraints or some combination of those. But we need a way that whatever we implement there is going to guide all of the contribution modalities. If it's somebody coming in through quick statements or a form or whatever, that it's all really handled in very much the same way. So that's a kind of a brief overview of what we're going, where we're going with this, some of the motivation behind it, some of the history of how we got to where we are, and our current challenge in trying to get to the tipping point where, this really becomes something that is not, um, just a passing fancy, but is something that is going to stand the test of time and really enters into active use for a lot of different things that we can apply it to. So I'd love to hear some questions, comments, critiques, and input on this. Maybe discover some other partnerships to pursue.
Great. Thanks a lot, Sky, for this detailed presentation about the work. And we do have a lot of time for questions and discussing. Anyone wants to go first?
Yeah, John.
Hi, Sky. How are you doing?
Yep.
Good.
Very, very nice to see you and see yet another of your fascinating talks and work being done. Very cool. The I got a lot out of all of that. I wanted to focus naturally, being who I am and what I do, on the aspect where you talked about contributing knowledge to the commons, which this is, I think, a brilliant demonstration of, and I think getting the buy-in from USGS institutionally to make this a basis of its work, knowledge work, it would be really great. And, and then at the end, you were starting to talk about the semantic relationships that you're forming. And so can you please talk about the path, the fastest viable path with minimum viable product that gets semantic, at least semantic terminologies, not necessarily all your RDF, but just statements about the semantic concepts that you have in this system, into a form that they can be searched and mapped in the semantic framework of our time, which would be RDF, at least OW or
Yeah.
SCOS as appropriate.
Yeah. So we started the kind of mapping of concepts, or the development of the fundamental ontology of classes and subclasses, at least in this too, from a USGS source that kind of made sense at the time. Peter Schweitzer's work on the USGS thesaurus, which is a SCOS vocabulary that's been in long use, and it has a lot going for it in a lot of ways, but it's also one of those efforts that wasn't really designed to scale to everything that it needed to cover. But we said, okay, let's start there and let's ingest the thesaurus and everything from the thesaurus and start to see how that plays out and how that gets organized and whatnot. And we did that because that was the basis for describing USGS science to a great extent. I mean, we use those terms and the concepts there in that way. And basically, I mean, what we've done is every single time we need to ingest some new chunk of source data, whether it's information on our people, information on our products. Every time that comes along with some form of keywords, whether how good those are, or how deep those are, is up for question a lot of times, but some of them are pretty good. We basically take a pass and we say, can we assume that this is probably the same thing as something we already know? And I mean, essentially having a place where we can say, this is what we've nailed down, and we're fairly comfortable with these concepts that are here. We're fairly comfortable with how they sit semantically in terms of their relationships to other things. We're fairly comfortable with how they are documented in terms of their sources and where we got them. That allows us to kind of have at least a basis of understanding every time we have to digest something new. So that we can say, okay, what does this new thing introduce that we didn't already know about? And that becomes the set of edges that we have to work on, of saying, okay, these are new things that we haven't dealt with yet. So then what do we do with those? What community vocabulary do we go to? What formal ontology do we go to? What other source can we go to that gives us a firm basis for understanding this thing and figuring out how to integrate it and how to ingest it into our overall knowledge base in some way? And we end up with this really kind of crazy thing in a lot of ways. And I should have thrown one of those graphics in here where you have this sort of dual path for a lot of our concepts, where you have something that tracks along and ends up in basic formal ontology terms and whatnot at sort of the top of the entity hierarchy. And then you have another path that takes you through more of the folksonomy world of terms and concepts that make good sense to some people, but they weren't exactly the same thing that we were thinking of here. And we're just kind of saying that's okay to do. It's okay to live with that. We're not going to have sort of the perfect, end all be all ontology that we're going to be able to work against. It's whatever it is at any given time.
So can I repoint this a little bit, because it was very interesting, the difference between where I was trying to go with the question and where you went. Where I was trying to go is, how can we make this more accessible and interoperable to the world? And where I think you went is, it's really hard to make this perfect. And it's really hard to make it even sensible, let alone perfect. And we're going to work really hard on that. And my worry is that we've had this conversation for 20 years now, that I went to USGS at the beginning of MMI and said, we really need your vocabularies. We really need them to be available to the world. And it's 20 years later, and I can find one of them on one of our repositories, but it's because somebody personally just tried it and they didn't make it public.
Right.
And
yeah, no.
Can we talk about that side of it? Is there a good path? Is there a path?
To answer your direct question, it's accessible now. The reason that we've done things the way we have on gokb.wikibase.cloud is to put it out there, even though we know that it's not perfect. And we've put caveats on it and said this is work in progress. This isn't official USGS thing yet, whatever it's going to be. Where this will kind of make its debut is sometime early next year. I'll take the whole thing as it stands at that time through an official release process. We'll put it out there, we'll have it sanctioned, and it'll be the thing that it will be, right? But I would love for folks to be poking at it and experimenting with it now. The Sparkle interface is there. It does have limitations. You're going to have to use some limits and offsets if you want to pull a great big record set. If you try to do anything really complicated in terms of deep traversal through the graph, you will hit snags and it won't return query results. So those are things that we're working to resolve. Like I said, with a different interface, a different Sparkle interface that'll give you that. So yeah, that's there now, and I would love for other people to poke at, especially some of the same as relationships that we've developed. I mean, you have to get those through property P84 in Wikibase. OWL : same as means something different than same as, but that is our declaration of this thing is pretty much what we have. So we've been going through the suite ontology terms as we run into things that those deal with. We've been working with global change master directory keywords, because those are still important too, and developing those connections. So we're trying to do as much of that as we can iteratively, and we'd love for people to poke at it and give some feedback.
Great, thank you. I'll follow up with you on some of the detailed questions. That's really wonderful. Great work all around. Very nice.
Yeah, just additional comment. Recently, I was even digging into some really old documents. I found some joint reports between NASA, USGS, NOAA, published in the middle 1990s about GCIS, GCMD words, and also some initiative like ideas or thoughts about using those common vocabularies. It's really interesting. And they also mentioned the idea of ESIP. I think back to that time. Yeah. I think that was like the starting point of ESIP.
Yep.
Good. Okay. So think about time. So we can stop it here. Thanks a lot again, Sky, for all those details about the work, and then how to translate the next data into linked open format and make them useful to the community. Thanks a lot. And then next we have about 15 minutes. Jim, probably you can stop recording.